Hello students, welcome back to the next module of our chapter called electrostatics. Now students, in this particular module, we'll be learning a very important concept of common potential. Now students, this situation of common potential arises when multiple capacitors having different capacities and different potential are connected in parallel with each other, right? Now for our reference, we'll consider only two capacitors in this situation, right? So let's say if we are having two capacitors, let's say first capacitor which is having capacity C1. So this is the first capacitor which is having capacity C1, right? Charge on this particular capacitor is Q1, right? So I can write charge it is equal to Q1, and the potential to which it is charged, it is equal to V1. So let's say I can write potential, it is equal to V1. The way we have considered first capacitor, now let us move towards the second capacitor, right? So let's say this is our second capacitor which is having capacity C2, right? And charge which on this particular capacitor, it is equal to Q2, and the potential of this particular capacitor, it is equal to V2, or it is charged to a potential of V2. Now students, let's say these two capacitors which are having different capacities and different potential level, let's say they are connected in parallel with each other, right? So let's say these two capacitors are connected in parallel, right? Now see their potentials. First one is having potential V1, second one is having potential V2. So there is a potential difference. So whenever there is a potential difference, I can say exchange of charge will take place, and this exchange of charge is taking place due to the difference in potential level, and this exchange of charge will continue till the time potential of both the capacitors is same, or I can say when till the time both the capacitors reach to a common potential level. So let's say these two capacitors are reaching to a common potential, let's say it is capital V, right? And in this particular situation, we are supposed to calculate the value of capital V, right? Now let us move further, right? Now students, common potential V, it is given by total charge of the system upon total capacity of the system, right? Now see, first capacitor, total charge is Q1. Second capacitor, total charge is Q2, right? So I can say total charge of the system will become Q1 plus Q2. So I can write capital V, it is equal to Q1 plus Q2, right? Now see these two capacitors, how are they connected? They are connected in parallel. So the total capacity of the system will become C1 plus C2. Right? So common potential V is given by total charge of the system upon total capacity of the system, right? So let this be my equation number 1, right? Now student, for first capacitor, I can write C1, it is equal to Q1 upon V1, right? From this we will get the value of Q1. So Q1, it is equal to C1 into V1, right? So the way we have calculated Q1, in the similar sense, we can calculate C2. So C2 can be written as Q2 upon V2, right? And from this I can write Q2, it is equal to C2 into V2, right? Now I've got value of Q1 and Q2, right? Now I'll be placing the values of Q1 and Q2 in equation number 1. So what will I get? I'll get capital V, it is equal to, right? Value of Q1 is C1 V1. So I can write capital V, it is equal to C1 V1 plus value of Q2 is C2 V2. So this will become C1 V1 plus C2 V2 upon total capacity is C1 plus C2. Right? So students, this is nothing but the expression for common potential when two capacitors are connected in parallel with their like plates connected together. Like plate means positive plate connected to positive and negative plate connected to negative, right? Now let's say if unlike plates are connected, then the equation of, or rather expression of common potential becomes capital V, it is equal to C1 V1 minus C2 V2 upon C1 plus C2. Right? So if like plates are connected, common potential is C1 V1 plus C2 V2 upon C1 plus C2. But if unlike plates are connected, then the common potential is C1 V1 minus C2 V2 upon C1 plus C2. Now let's say the second capacitor that we have connected over here, let's say that second capacitor is uncharged. And as second capacitor is uncharged, I can write value of potential, that is V2, it is equal to 0. And if I put V2 equal to 0 in the above expression, what will I get? I'll get C1 V1 plus 0, right? And C1 V1 plus 0 will become C1 V1. So common potential V will become C1 V1 upon C1 plus C2, right? So here we have also considered multiple cases in case of common potential, right? Now let us solve one multiple choice question which is based on the same concept. Here a capacitor of capacitance C1 is charged to a potential V, and then charging battery is disconnected. It is then connected in parallel to uncharged capacitor of capacitance C2. What will be the potential difference across each capacitor? right? So let us start with the solution. Here, two capacitors are connected in parallel, and when two capacitors are connected in parallel, they will come across a common potential difference, right? So common potential is given by V dash. In this situation, it is equal to C1 V1 plus C2 V2 upon C1 plus C2, right? Now let us move further. Now first capacitor is charged to potential V. So in this case, I can write V1, it is equal to V, right? Now second capacitor is uncharged. Now as second capacitor is uncharged, I can say V2, it is equal to 0, right? Now if we place these values in this particular equation, what we'll get? We'll get V dash, it is equal to C1 into capital V upon C1 plus C2, right? So which is the correct answer? In this case, option A is the correct answer. So students, in this particular module, we have covered the concept of common potential. So that's it for this particular module. I'll see you in the next module. Till then, keep learning.